All right, so in this video, we're going to look at overloading the insertion operator for our VPET class. So we wrote this VPET class in a different video, and toward the end of that video, I said that it would be a good idea for us to overload the insertion operator for this particular class. And what that would allow us to do is write statements like cout, and then the insertion operator, and then specify a VPET object and have some sort of representation of our VPET object sent to the console. Now certainly we could also send it to a file or whatever it may be. So the very first thing that we need to do in terms of writing this overloaded insertion operator is to write the function prototype or the function declaration inside of the vpet.h file. So what I'm going to do is have our function prototype specified in the public section of our class. But this particular function is not going to actually be a member of this class. It's going to be what we call a friend. So a friend function just simply says that we can have access to the private data members, but again, it's not an actual member of the class. So the way we go about defining something as a friend is by using the keyword friend and then specifying the rest of the function prototype. So in this particular case, we'll just say friend std : ostream ampersand. So we're saying that we're going to be returning a reference to an ostream object. And the reason why we need to return a reference to an ostream object is so that we can actually chain multiple insertion operators together. So we'll do that, and then we'll say operator, and then whatever operator we're overloading, in this case the insertion operator, then an open paren std : ostream ampersand. So we need to pass in a reference to an ostream object like cout or a file or whatever it may be. And then we'll have a constant reference to a VPET object. So we'll pass that in by constant reference, and we'll just have the identifier of VP associated with that particular VPET object. So that's it for our function declaration, and then we'll go into the vpet.cpp file and write our function definition. All right, so before we go over to the vpet.cpp file, I did want to mention that we really don't have to have these identifiers here of OS and VP. So for the function prototype, function declaration, all we need to have is the types being specified there in our parameter list. So let me go ahead and just copy this here, everything except for the friend part. And I'm going to just go over to our vpet.cpp file and go down toward the bottom and paste this in. So we'll get rid of this semicolon here, since we're actually going to be writing our function body instead of a function prototype. It just turns out that the function header is the same. And then we'll have open brace, and then press enter, and we should have a closed brace that was inserted automatically. And now we can think about what we should be doing inside of the body of this overloaded insertion operator. So what we really want to have is the ability to have a representation of our VPET object. So we think about each one of our VPETs having really two properties associated with it: the weight associated with the VPET object and whether it's hungry or not. So what we can do is start building up a string that represents whether our VPET, our virtual pet, is hungry or not. So we'll declare a string, so std : string, and we'll name this string just hunger status. So hunger status, and we'll set it to the empty string initially. So below that, we'll have an if statement in which we are just going to ask a question and find out whether our particular VPET is hungry or not. So the way we'll go about doing that is just an if statement and then say VP, and then if we do the dot operator, we should get a listing of all the properties and methods associated with this particular virtual pet, and we can access the value of being hungry or not directly, since this is a friend function. So we can do vp.hungry, and then do open brace, close brace, and then we'll say hunger status and set our hunger status appropriately. So we'll just set hunger status to hungry and do a semicolon. Otherwise, else, we'll say that hunger status is set to not hungry. And then the final thing that we need to do, and we're just keeping things very simple here in this particular overloaded insertion operator. So the final thing that we'll do is just do a return statement. So we'll do a return OS, which is our reference to our ostream object that we passed in, such as cout, and then do another insertion operator, and then just say wait. So we'll have just a string literal there called wait, and then do another insertion operator, and then do vp dot weight, so we can select that if you want to, and then do another insertion operator and do double quote, space, hunger status, colon, space, and then do another insertion operator, and then we'll say hunger status. So that just is going to retrieve the value that we have stored there in our hunger status variable, and then do another insertion operator, and then do std colon colon indel to have a new line character inserted there. That may be a little bit too long, so I'm going to bring this down to the next line. And that's pretty much it for our overloaded insertion operator. So all we're really doing there is just building up some particular string that we want to have sent out to OStream. So the insertion operator is being used multiple times in this last statement that we just wrote. The insertion operator is, in fact, left to right associative. So this is the first operation that's going to occur. So what's happening here is we have on the left-hand side of this insertion operator an OStream object, or a reference to an OStream object, and on the right-hand side just a string literal. So after this particular operation is performed, we would have a reference to an OStream object being returned so that we can do the chaining here. And now in this particular case, all this stuff would resolve down to a reference to an OStream object. So that's what would be on the left-hand side. And then on the right-hand side, we would just simply have a weight here, which this weight is of type double. So that it knows how to handle that as well. So OStream object reference, and then a double, and it knows how to handle that. So we're now at the point where all the time that we're using the insertion operator here inside of this return statement, we already have the insertion operator defined for those particular types. Okay, so before we go over to our vpet app.cpp file and test out our insertion operator here for our vpet class, I noticed that I had a little typo here, so I should have had just one U here for hunger status. So go ahead and save that, and now we'll go over to vpet app.cpp, and what we can do inside of main here, instead of having these if statements here, we can just take this bit of code out, and we'll just do a cout insertion operator, and then specify Bob insertion operator indel, and we'll do the same line of code basically, except on the next line we'll do it for Sam. So we can specify Sam here, and then we'll save this particular file and then build it. See if everything builds okay. So it looks like everything built okay here on the console, and now we'll go in and run it. And so whenever we ran this particular program now, you see the same lines that we had before for Bob Ways and Sam Ways, and we also see that we have these two new lines here. Now you notice that we don't have anything being output associated with Bob and Sam on these two lines, or at least the name Bob and Sam, and that's because the overloaded insertion operator doesn't have any mechanism to actually retrieve the names Bob and Sam, since Bob and Sam aren't actual properties. Those were just simply the names that we associated with these virtual pet objects. So we could have named them anything, but that's not an actual internal property. So if we go back and look at vpet.h, you see that we don't have a name specified here. Certainly we could have added that, and it would have probably been a good idea. But yeah, we do in fact have the weight and status for both Bob and Sam being printed out here because we made use of overloading the insertion operator. So that pretty much concludes this particular video, and hopefully you have a better understanding of overloading the insertion operator and how you can go about doing that and other classes that you may write. You know, the big idea here is that whenever you do overload the insertion operator, you're just wanting to have some sort of representation for your particular object. So in this particular case, we're just representing whether our particular virtual pet was hungry or not, and also the weight. All right, so that's it for this video.